Hello everyone. So here we are going to see another measure by which we can measure the strength of an edge. So this idea is known as neighborhood overlap. The neighborhood overlap of an edge connecting two node A and B is the ratio of number of node who are neighbors of both A and B and number of nodes who are neighbor of at least A or B. Okay. So let's see a couple of examples. So here for the first example, so we are going to calculate the neighborhood overlap. OIJ means the neighborhood overlap of edge VI and VJ. Okay, so for this edge, so the number of neighbor, the number of no, the number of node A who are neighbors of both A and B. Okay, and the by number of nodes who are neighbor of at least A or B. So here we can see that the number of node who is neighbor of both Vi and Vj, we don't have any mutual neighbor. Okay, we don't have any common neighbor, so here the value is 0 by total number of neighbor has either A or B has say 1 2 3 4, so which is 0. Now for the second graph we can see that the number of neighbor, so let's give the name A and B. Okay, the number of neighbor both A and B share is 1 and 2. Okay, so the neighborhood overlap is 2 over the total the number of neighbor either A or B has. Okay, so 1 2 3 4 5 6, so which is 1 by 3. So from this example 3 we can say that the common neighbor A and B both has 1 2 3 and 4, so 4 over, so total number of neighbors either A or B has, so 1 2 3 4 5 6, so 2 by 3. And here this is, I think this is going to be 6 by 6, 1 2 3 4 by 6, 4 5 6, so total 6 friend both A and B has, and all of them are actually connected, so they have 6 common friends, and the total number of friends also they share is 6. Okay, so which is 1. Now this idea of neighborhood overlap also say us the measure how strong the edge is. Okay, the strength of edge we can also measure as a using this measure, then using calculating the common neighbors between them, which is known as neighborhood overlap. Now if we look at the local bridge, the local bridges are going to be have always the neighborhood overlap 0. Okay, so you can find that out that all the local bridges will have a neighborhood overlap 0. So what it means that, sorry, so what it means that if a bridge if a edge is a local bridge, all right, that means and the connecting two endpoint will not have any common friend, okay, common neighbor. All right, so A B, okay, now according to the definition AB is a local bridge, and if AB is a local bridge we can say that the connecting two endpoint A or and B will not have any common friend. Okay, and by that we can conclude that AB, if AB is a local bridge, they will always have a neighborhood overlap 0. Okay, now we can think of edge with very small neighborhood overlap also, like being a almost local bridge. Okay, so if the ratio is really very small between the neighborhood overlap between A and B, then we can say that this is also like maybe not completely local bridge but also like a almost local bridge. So for now let's see what actually we are thinking about the strength of weak tie. So in the whole discussion we actually discusses the structure of the relationship between people. Okay, relationship between nodes, and we classified the nodes as either strong tie or weak tie. So structurally defined, there are definite structurally defined, there are difference between strong tie and weak tie. So strong tie means more closeness, more friendship, more times together, and weak tie means, in our real world also, weak tie means it's a long range of friendship. It's is going to be a weak tie. That means it's not a friendship, just a acquaintance. All right, now we are saying that this tie is a weak, but how, but also this tie is a strong. So what it means that, in perspective of information flow, a weak tie is a weak tie possesses some strength. So the removal of weak ties actually the raises path lengths more than removal of strong tie. Okay, so think about that. If we are going to consider a graph like that, okay, let's say a couple of strong tie in between, inside the community, okay, and one weak tie or one or two weak ties between the communities, like that. Okay, now if we remove the weak ties, that actually raises the path lengths more than removal the strong tie. So what it means, if we remove a strong tie like that, okay, still actually the node, this guy and this guy, the node, let's name them n1 and n2. If we delete the strong tie between n1 and n2, n1 and n2 is going to actually going to still connected by through other mutual, by through other friend. Okay, so in this example, if we remove this edge, the path between n1 and n2 will become, instead of 1 directly 1, it will become 2. Okay, now if we delete this edge, okay, let's see, here is a node n1 and here is a node n5. Okay, now with this edge, the path between n1 and n5 is 1 2 3. Okay, all right, now n1 and n5 is connected by distance of 3. But if I delete this edge, the weak tie, in that case what is going to be the connection, what is going to be the path between n1 and n5? All right, so let's see, we have this strong one, so this is going to be 1 2 3 4. Okay, now even if we don't have this weak connection, this is going to, this can actually raises the path length more than removal the strong tie. So strong tie means actually all of them know each other, but weak ties are, can be some, in some community weak ties can be the only path, or one of few paths that is connecting two communities. Okay, so that's how, if we remove the weak ties, that is going to raise the path lengths more than removal of the strong tie. All right, so we can assume that the probability of information passing successfully between two nodes is proportional to the number of paths connecting two nodes. So, and we can conclude that if we remove the weak edge, that can actually damage the connectivity more than removal of the strong edge. Okay, so we saw that if we remove a weak edge, that can actually partition two network, and if we remove a bridge, that will partition the two network completely. But if we remove a local bridge, generally that that actually increases the path between two nodes, at least with the path with length at least more than 2. Okay, so from all of the discussion, we can conclude that the removal of weak edge damages the connectivity more than it does the damage with the strong edge. And also another strength of weak ties is community coordination. So without weak link, community exists as a set of strongly connected but disjoint clique. Okay, so let's see the example again. So some strongly connected clique or some strongly connected group but no weak tie. Okay, so without weak tie, this community exists like as a set of strongly connected but totally disjoint clique. Okay, so in that case no one is going to be suitable to act as a leader for all. So these are all some disjoint set. There is not going to be any people, any leader who can act as a leader for every group. Okay, so if there is no weak link, if there is no connection between these two communities, there is not going to be any chance that can bring all of them together. Okay, so another strength of weak tie is access to resource. So our weak ties are with people whose ties are with those socially distant to us. Okay, and those weak ties actually bring us knowledge of our community not available through friends. So as we discussed, that the strongly connected group are also like redundant with information. So you know, in this group all of them know each other, so all of the resources information will be actually known by each other. So there is less likely that a new information will pass through between a strongly connected group. Okay, and that's how weak ties always bring us knowledge in our community which will not be available using only by through strong friend. So what it means, many weak tie means more access to wider communities idea. So let's say this one is a community, this one is another community, and community 3 and community 4. Okay, so if we have multiple weak tie, and this weak tie is going to actually many weak ties means there is going to be probability that wider probability that more access to wider communities idea or resources, and few weak tie means little information to the outside world. So if there is no any weak tie, that means you are going to be actually you are going to have information which is only available in your community. Okay, so many weak tie means more access in the outside world, and few weak tie means little information from the outside world. So from that discussion we can actually come up with that from using the Granovetter's theory, we can consider our now network communities as a collection of community and a collection of some strong tie and weak tie. So we are visiting the same figure again. Now from that figure and from all of the knowledge and all of the theory we have learned so far, we can say that a network means it's a collection of community and a collection of strong tie and weak tie. So all the ties inside the community we can consider them as a strong tie, and all the tie that connects two different community together we can consider them as a weak tie. So for example, this one is a weak tie and this one is a weak tie.